protocol, which Mr. Rahul is thinking, is known as actually your hot standby routing protocol. Okay, we had questions, right? Okay, Mr. Burak and Mr. Mukund, let me finish this board. And after this board, if you have any doubt, then you can ask. Okay, but thank you so much for raising your hand, because I am not done with the discussion of HSRP, right? So what is happening here, guys, is right now I have just included internet also, but it is okay. It is the same thing, right? So whatever the virtual IP address and router I was showcasing you, it is right here. This one is the virtual router. It is going to have the IP address 192.168.10.1/24 and MAC address E:E:E, and this is the default gateway for VLAN 10. I have configured another IP address here, which is 10.2, and here on the green, which is 10.3. As simple as that. This PC is having IP address 192.168.10.10. This PC is having IP address 192.168.20.10, right? And then, of course, /24, right? So now, one thing which is really interesting. Suppose right now, this guy is active and this guy is standby. Let's consider this case, because we now understand switching very well, right? So let's think from the perspective of AC1. What is happening here? So suppose this is my interface 0/2. This is my interface 0/3. Suppose, right? What is going to happen if 10.10 wants to communicate to 20.10, means between VLANs, it is going to go to its default gateway. It is going to send the ARP message here. ARP will be going here. I am presuming this link is blocked because of the STP, because this link and this link is up. What is going to happen? This guy, virtual router, is going to reply, because now the virtual router is the property of active, right? If that is the case, we are going to get the reply or reply from here. And what is building on this access switch? You all know about it. Switch is building its CAM table on the basis of source MAC address. It is going to contain the VLAN, MAC, and the port. Really interesting. What is going to be then the VLAN? Because we are talking about VLAN 10. MAC is going to be E:E:E. And from which port it is learning? It is learning this address on port 0/2. Everything is fine, no problem at all. And if this PC wants to go towards the internet or the PC VLAN 2, it is going like this for sure, right? Actually, the traffic should be first it is coming to the virtual router. Virtual router is a property of the distribution switch. Then it is going out towards internet. There is no doubt about it. Easy. Now, let's consider another scenario. Very interesting. Now, what is happening, guys, is suppose this link is, or this distribution switch is down. If this is down, then this is also down. It means that spanning tree has to make this port up. If that is the case, right? And suppose this guy is downloading something from the internet, from the server, and it's a 7 GB file, and during that operation happens. Believe me, this guy is going to send the message to switch, right? Because it has resolved the MAC address of 10.1, which is its default gateway, which is E:E:E. So it is not going to do again address resolution protocol, right? Because why do we use ARP? We use ARP so that we know what is the MAC address corresponding to my default gateway or a host which is in my same network, right? Here I'm talking to different network. It means that I need to know that ARP or the MAC address of 10.1, which is the responsibility of ARP, right? It has already done that. It is not going to do the ARP again. And that is my problem. If that is the case, my CAM table on switch 1 is still pointing towards 0/2 interface, which is down now, right? Or maybe it could be the case, extremely sorry for this, that maybe this VLAN interface is down. This interface is maybe again say up, right? Or you can think that right now, basically this PC is saying that EEE is on 0/2 and 0/2 interface is not there. Maybe this entry is down, gone, right? Nobody is doing ARP and still it's a problem, right? So you can understand for the unknown unicast also, which is going to do the broadcast. So eventually this guy will be learning it, right? But suppose in some case, right, this link is also up and this switch is learning still EEE on 0/2, then that is the problem. If that is the problem, what is the solution for the end? Mr. Rahul doesn't have any answer for this, right? But he thought interesting thing now. He's saying we have learned the concept of gratuitous ARP, right? Can we use that? And believe me, when 10.1 IP address was on the active router, right? And when standby become active, before getting this IP address, believe me, this guy is going to send the gratuitous ARP on this 0/3 interface. And what is the gratuitous ARP? The ARP reply for my own address, right? It is just the reply message. Why we use it? To let everybody knows that I am 10.1 and here is my MAC address, which is E.E.E. So whenever the standby router takes active role, it is going to send the gratuitous ARP. And that is why the switch will be having another entry, 10 E is learning over 0/3 interface. And switch is going to always trust the recent entry. Then shouldn't be any problem with respect to this traffic flow. As simple as that, right? The MAC address allocated by HSRP protocol, right, to your virtual IP is actually fixed, right? At least the starting few bits are fixed, which are 0000, 0C07, and ACXX. The meaning of XX is the group. What is the meaning of group? So right now, you have to say that distribution 1 is your active router. It means that you need to set the priority of this router. That is it. And you need to set the what is going to be the virtual IP. That is it. Only 2 commands are needed, right? And where do we need to do that command? On the VLAN interface. Suppose I have created, or the SVI interface. I have created interface VLAN 10 here. Of course, I have given it the IP address as 192.168.10.2. I'm talking about distribution switch 1, right? Then I have to say standby. This is standby protocol is part of group number 10, and the virtual IP address is 192.168.10.1, which is my default gateway, right? And then I have to say here that the priority is 200. I want this distribution switch to be active when it comes up. On the second distribution router, believe me, the configuration is again really simple. You need to configure the IP address, which is 10.3, and you need to say standby 10 because this group is the identifier that, of course, right, these distributions 1 and distribution 2 switch belong to the same addresses, sorry, same group, and the virtual IP is 10.1. And believe me, when they say hello to each other, they are going to say that my priority is 100. Sorry, 200. It is going to say my priority is 100. Why? Because 100 is default in HSRP. Who is going to win? Distribution 1 is going to win. It is going to take the role of active router. As simple as that. We have discussed some of the nitty-gritties, right? So by the way, this XX is actually your group number. So whatever your group number is, you are going to get this number here. For example, in hexadecimal system, If we have group number 10, then in hex we write it A. So basically this is going to become your 0A. This is going to be your HSRP MAC address, which is going to be same. Doesn't matter if it is on active router or on a standby router which just become an active. As simple as that, right? So this is your HSRP protocol, right? And now I am open for question. Mr. Burak, now you can ask your question. Please go ahead. Mr. Burak, you are on mute if you are talking.
Sorry, Vishnu. My question is about preemption.
Yeah.
For which scenario should we use preemption option for the HSRP?
Yeah, so some of the things which I am deliberately leaving because I believe if you have fundamentals clear, you can do that, right? But if you have specifically asked, for example, suppose we have two switches. This one is my distribution one, this is my distribution two, right? This was active, this was standby. Something bad happened to this router, right? Then what is going to happen? Hellos are going to be lost by D2 and D2 will become the active. And this is down. But after some time, suppose you done some magic and this guy comes up again. Now the question is whether this standby, this will become again the active or standby, right? If you do not do anything, then basically when this router or the switch or distribution one comes up, it is going to be in the standby state. Doesn't matter whether its priority is high or not, right? But if you do not want that, you want that no, when it comes up, it should be my active router, right? Because maybe you have more, you have great internet connection on this switch as compared to this one. So you always want that whenever this router come or this switch comes up, it is going to be my active. So you can say the preempt time, the preemption meaning that if I come back again, I was active router, now I am standby, right? But if I come again, you can say I want to configure a preempt value. Preempt means I can take my active role back, and you can suggest that when I come back after 50 seconds, I want to become again the active router. You are giving this 50 seconds so that this switch basically goes through all these listening, learning stages of STP. Let's make this switch settle down, and when it settle down, then basically it should become active again. So preempt means you want to take your previous role. You whatever whoever is the active, you do not care. You want yourself be active because your priority value is more, right? But if you do not configure preempt here, Burak, then basically this switch is going to be in standby state until unless active goes down. Okay.
Okay, Vishnu. My other question is when or for which situation should we change the default HSRP timer values?
Okay, this is interesting. So I will be talking about HSRP when I will show the packet capture for this, but by default, the time for these hello messages is 3 seconds. And if we miss 3 consecutively messages, then my standby become the active, right? So if under normal condition, if you do not change this timer values, then 9 seconds will be the time period for which this standby switch has to wait, right? Before becoming an active. So until unless it misses 3 hellos, it is not going to be active again. So it is up to you how much time you want to decrease, right? From 3 seconds, if you want to make it to 3 seconds from 9 seconds, you can configure the hello timer as 1 second. But for that, the downside is your hello traffic is going to be more on this interface. Every 1 second you are going to send. I'm not sure whether you can configure the hello value as per milliseconds also, but I need to check that. So the situation is
Let's say
basically if you want to have this change from active to standby pretty rapidly, you need to change the hello timers. Okay.
I see. For example, maybe we want subsequent convergence.
Yeah. Yeah.
In this case, we should decrease the HSRP timer as much as
Maybe
possible,
three.
very small
That
value.
is what I'm saying. That I need to check whether we can configure this hello timer value less than a second. Maybe if for your condition it should be around 300 millisecond, right? Because 300 millisecond into three time is 900 millisecond, which is even less than for 1 second. So you can achieve
Yes,
that,
yes.
but we need to check whether the millisecond value can be configured. I'm pretty sure that we should be, but I haven't checked it. Mostly I've seen this 1 second value in many places, but let's check it. Maybe I can confirm you in the next class. Okay,
Okay, okay.
perfect. Good questions. Then let's go towards Mr. Roshanji. Mr. Roshan, please ask your question.
Hi, Vishnu.
Hi, Roshan.
Vishnu, first of all, hi. Vishnu, there is a distribution 1 and distribution 2. They are connected point to point, or the hello packets is going via the access switch?
Actually, right now I have connected them directly, and that is why I'm saying that if this guy is my active router or it's spanning to root also, I will be discussing about that issue with you also, that what is the impact of root switch on standby or basically on HSRP. But right now, distribution 1 and distribution 2 are connected. So this port is going to be my designated port. This is designated because this is root, and this is going to be my root port for this switch, root port for this switch. So basically, in a normal scenario, this link and this link is up, right? So the hello messages are going over here. But you are absolutely correct. If we do not have this link between these two guys, believe me, we can use this mode of hello message communication also. Okay.
The reason is that why I asking this question. If distribution 1 and distribution 2, in between these two point to point link only link is goes down. In that case, I think they have the split brain scenario. At that time, how will they handle the traffic?
Okay.
Only link is goes down. No.
Okay. Let's talk about that, because the split brain scenario is not going to be happening here. I'll tell you why. Okay. Let's see that. For example, suppose this is the link right now and the hello is processing over it. Okay.
Right.
Now, if that is the case, then of course we have a, if this goes down, then basically this is your root. If this is your root, this is going to be the root port. This is designated port. This is my designated port, and this is root port, right? So the STP topology is going to be like this. Still, these two switches are able to communicate with each other, right? Hellos, previously they were going here, now they are going here, right? Still there is not going to be split brain. Why? Because both switches are communicating with respect to hello. But yes, you are absolutely right. If we make sure that this link also goes down, right, Mr. Roshan? If that is the case, then it's a problem. This switch now understand that this is my I am the active one, because it stops getting any hellos, right? Similarly, distribution 1 was already active, so this was active, right? But with respect to the traffic flows and all, everything is going on to this router according to this topology. So, but whoever is connecting here, it is going to think that the default gateway is right here. Okay, but still, in this case, I do not see any problem, right?
The hello packet HSRP hello, I'm asking about HSRP hello. If the point to point goes down, HSRP hello automatically shifted towards the access switch.
Yeah, this point to point link is also the trunk link. Everything, whatever is between these switches is trunk. I forgot to mention you. Okay.
Okay, then it's fine. Yeah.
Yeah.
Then that time it's
point to
still
point.
having
Basically,
the
I think you are getting little bit confused with the VPC. In VPC, this point to point link is actually there are two links, which is a peer link and we are going to talk about it. But definitely in this case, it is not going to be much problem. But yes, you are right that if we somehow If we block these two links, right, then both of these HSRP routers will become active. Okay, you are right in this.
Yeah.
Yeah. So
Okay. Fine.
having said that, let's talk to Mr. Prashant Patilji. Mr. Prashant, please ask your question.
Yes, Vishnuji.
Mm-hmm.
So in this case, how do you avoid this asymmetric routing? Let's say distribution switch 1 is acting as a master and distribution switch 2 is a secondary. So the traffic will be going from the PC1 to distribution switch, and it will reach internet, and we don't have control on the return traffic, and it will be coming to distribution switch 2, right?
Yes. Yes, it can come to
So,
distribution too. Right. Yeah.
okay.
But what is the problem? See, most of the time, if you see this asymmetric path, right? Believe me, asymmetric path is not a problem until and unless you have some firewall in between. And there is a specific case I think I have explained somewhere. But right now, for example, if your traffic is going from this router and coming back from another router, right? Suppose, and you have a firewall somewhere here. So this firewall will not see the traffic which is incoming, and firewall basically let the traffic come if it is initiated from the inside port, right? By default. So this case, basically this the asymmetric routing is a problem. But here it is not routing it at all, right? Suppose what is going to happen? This is going like this, coming like this, right? The return traffic can be right now means if you are using the HSRP thing, right? If this is going over 10.1, definitely you will be advertising that return traffic will be coming on the basis of whatever the NAT IP address you have given. I haven't made another, I should have made another router, or basically this distribution should be doing NAT. So you will be advertising a public IP address. The return traffic will be coming on this switch itself, right? Because the netting is happening here, right? But yes, if sometimes this switch goes down and this comes up, then netting will be here and you will be going out from here. The return traffic will be coming like this only. Okay.
Okay.
So basically there is no traffic asymmetric routing, but asymmetric routing is not a problem in all the times, right? Asymmetric routing is a problem if a firewall is somewhere. Okay, Prashantji?
Okay, and I have one more question. Let's say there is a communication failure between distribution switch 1 and switch 2.
Okay.
Okay, in this case, if I give show standby brief, so will I be able to ping the virtual IP? So both are acting as individual virtual gateway.
Individual virtual.
From the PC one.
So basically, you are saying that if this link goes down and this link also goes down, you are saying?
Yes. Now both are acting as a master gateways.
Yeah.
So in that case, will I be able to ping that virtual IP?
Definitely, because right now both are saying that they are actually owner of this virtual IP. 10.1 is here also, 10.1 is here also, right? Whoever is reaching to any router, he is going to reply back. Because, for example, if a PC is connected here, whose default gateway is 10.1, it will be reaching here, for sure, right? But yes, it's a situation in which you do not want to be for more than time. But try to understand you are reaching to this condition when we have only one access switch. But generally, you have so many access switches, right? And you must be connected like this way, right? If one link goes down, something else. So I am drawing this topology just to make you understand. But this is the topology which you are not going to see in most of the production network. In most of the production network, you are going to see many access switches which are connected to distribution like this, right? If this link goes down, if this link goes down, then still we have some connectivity from access 2, right? Interesting. So one thing which I would like to discuss with you, and I will come to you, Mr. Supreet has another question. Supreet, please do ask your question.
Hey Vishnu, thank you. So this might be just a follow-up question now. What I'm trying to think over is now, Now let's say, for example, we have one more switch between distribution switch and distribution switch 2.
Yeah.
And let's say, for example, I want to run HSRP on distribution 1 and distribution 2 itself.
Okay.
Now in this scenario, if distribution 1, the port which is connected to switch 3 of distribution switch goes down, how does distribution switch 2 know that the distribution switch 1 is down? Now it has to be active because the port for distribution 2 is still up.
So basically you are saying this link is down. There is no direct link between distribution.
No. The link between distribution 1 and switch 3 is down.
Distribution
but
1 and switch 3 is down. This is down. Okay.
Yeah. And the link between distribution 2 is still up.
Okay.
I mean the switch 3 and this is still up. So in this scenario, what will happen? Will be there any traffic disruption?
See, actually, if you are getting the hello messages, doesn't matter you are getting from here, you are getting from here, this distribution switch will be in the standby mode. That is it, right? I can still see if the link between distribution 1 and switch 3 goes down, there are so many paths, right? This path is there and this path is there, over which this distribution switch will be receiving the standby. Sorry, the hello messages here and from here. You're getting my point, Supreet?
Yep. Okay. Now, just trying to make it a little critical. Now, what will happen if the port between distribution 1 and access switch 1 also goes down?
Okay. Suppose this is also goes down. If that is the case, we have still one more path. Hello will be here.
But no, but I don't have direct communication between. I don't have point-to-point connection between distribution 1 and distribution 2.
So it means that you are saying that this link is also down.
Yeah.
Okay. Then basically there is no way that any standby switch will be, any hello messages is reaching to distribution 2. In that case, this will become active. This will also become active.
Okay, so this will be a split brain scenario then.
Yeah. So basically, if that is the case, then try to understand from the PC one, there is no way it can reach to distribution switch 1 because this link is down, this link is down, right? The only way is to go from here.
All right. Yeah. Got it. Thank you, Vishnu.
Perfect. Now, Mr. Burak and Prashant Patilji, I would come to your questions again, right? Maybe at the end of the class. So just write down your questions. Okay. One last thing which I would like to tell you is what is the relationship between spanning tree protocol and HSRP. And this is one of the most interesting things, right? Because people understand some of the things, but when we talk about how spanning tree protocol can affect traffic path in case of HSRP, believe me, it is going to be a pain for many people, but it is very, very simple. What we are going to do is we are going to use our STP knowledge to understand what is going to happen if we change spanning tree route. What is going to happen? Just try to understand. We have distribution switch 1, which is having the active role. If it is having the active role, then of course, this virtual IP 192.168.10.1, it's his property. MAC address, suppose E:, key is his property, right? No doubt about it, the traffic flow toward the internet is going to be like this, right? You all understand that. But now, suppose what I'm doing, I am actually making this switch as root switch. Try to understand what is going to happen. If this is the root switch in the STP topology, this is going to be my designated port because all the port on the root are designated, right? This ports toward the root is going to be the root port. And of course, one of these port is going to be the blocking. Suppose any port is going to be the blocking, this switch link will be down. STP topology is going to be like this. As simple as that. Eventually, your traffic is going to be following this path, right? Now, what is going to happen? If my PC1 wants to communicate to PC2, right? I want to draw with the green pen, right? How it is going to reach? It is going to go over this switch, then here on the distribution 2, where it won't be finding any 10.1 gateway, it has to travel over this trunk link. Then basically it is going towards this. Do you think this is the optimal traffic path? No. And that is why try to make your root switch, that switch which you want to have active in HSRP topology, or your active switch should always be the root of your topology. Otherwise, I'm not saying there is going to be a disruption in traffic. You are not going to communicate with the other host. No, but there are some extra hosts you need to travel. There are extra switches you need to travel, and that is it, right? And this is the most interesting question people asked in various interviews. And this is the, apart from the interviews, this is the most interesting problem you actually see in your network. Sometimes what is going to happen if this switch is a weak switch, if this switch is having a low quality internet connection, or maybe this switch is not as good as sending the traffic faster. Maybe it's a bad switch. Maybe this link is really, really poor. And the best link you have made down. If you do not have understanding of the spanning tree protocol and HSRP together, believe me, this debugging of problem is going to be very, 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 very difficult, extremely difficult, right? So try to understand. If you are learning Ether channel, STP is there. If you are learning HSRP, STP is there. If you are learning why behind VXLAN, STP is there. If you say, I do not want to stretch VLANs between multiple buildings, the core reason is spanning tree protocol there also, right? So spanning tree protocol is whole soul base of your switching, and people just leave it. People say it is difficult. It is not difficult at all, guys. I'm not saying you need to understand each and every nitty-gritty of spanning tree protocol, maybe RSTP, MST. No, absolutely not. But try to understand what is the role of STP. STP comes as a problem solver, right? It solved a unique problem of looping, right? But in most of the cases, we are seeing it itself become a problem, right? So if you want to understand switching, if you want to understand and appreciate the later technology which we are going to read about, right? The VXLAN and everything, you need to understand spanning tree, right? If you understand how to find out the root port, designated port, root port per switch, designated port per segment, only one. And if a port is neither into the category of root port or designated port, then it is going to be the block. That is it. As simple as that. Right? This is one of the most interesting scenario which I have encountered in some of the troubleshooting also. Maybe I can ask you what is going to happen if this link is really, really bad, right? If you understand the STP, you can draw this topology, and if you know HSRP, you must be thinking that we are adding one more switch, right? It is going to be great if I make my root switch as this one, right? Because if this is the root switch, then this link is going to up, and my default gateway is also here. As simple as that. Any doubt, guys? Okay, now I can go again to Mr. Burak to take his question. Mr. Burak, please ask your question.
Okay, Vishnu, thank you. My question is not about this picture. It's about rooted access design. If we use rooted access layer 3 design, do we still need to use HSRP in this case?
This is interesting. So suppose, let's take an example, right? You are talking about rooted access. So suppose we have these access layer switches, right? And Mr. Burak is saying that we have access layer 1, access layer 2, maybe access layer 3. And believe me, he's saying that whatever the link which are flowing above access switches, they all are actually layer 3. They are not layer 2 at all, right? These
In this
all
case,
links are layer 3.
there is no spanning tree exists in these links.
Definitely, there is no spanning tree because these are the layer 3 protocol. In fact, now what we can do is we can do layer 3 load balancing, right? Because we are learning here, right? And believe me, Mr. Burak, I will be having a lot of discussion regarding this topology, right? But to answer your question, suppose I have a PC here, which is part of my VLAN 10. Suppose, right? This is part of VLAN 10. IP address is 192.168.10.10/24. The problem is, where should I give the default gateway in this case? What should be my default gateway in this case, right? Because I believe you are making at least this port as access port, and this port is going to be, suppose, access port 10, right? I had to configure the default gateway right here, which is going to be 192.168.10.1, right?
Yep.
If that is the case, then of course my default gateway is right here in this SVI. But if this link goes down, or this SVI goes down, or if this access switch 1 goes down, then it's a problem, right? Although in case of PC, we do not consider it, right? But it is going to be good if I connect something like this, and I create 10.1 as a gateway here also, right, Mr. Burak? Right? So these are the things which I'm going to discuss with you, right? Because these are the whole soul things required to come up with the VXLAN topology also. Do not worry about it. But yes, this is a great question. Right now, if I just don't do this, then I do not need a HSRP here. But
because there is only one
yeah, but if you let me connect these two access switches amongst themselves over the trunk link, then I would rather run HSRP here, because now it is going to give me the default gateway on two different access switches, right? Over it, absolutely everything is this, right? But yes, between access switches, if you are running trunk to extend the VLAN, then I will be running HSRP here. But there are a lot of nitty-gritties with respect to this. Believe me, once we are done with this complete course, these kind of issues are going to be vanished from your mind. This is the whole soul thing I will be discussing. Do not worry. But yes, it's a great question. Mr. Prakash Rajsekharanji, you can ask your doubt, your question. Mr. Prakash.
So if we have two routers in a HSRP, and if we need some specific routes to be transferred via one router, so in this way, can we do this like without default routes?
I didn't get your question.
So usually HSRP is like it will be once one of the router down means it will take the other path, right?
Let's see what you're trying to say. We have two routers, R1 and R2. This is HSRP active. Yeah. This is HSRP standby. Now, let me know. And basically, there is a link between them, which is connecting them, and hellos are flowing over it, right? Suppose. And then we have, yeah, go ahead, Mr. Raja, Prakash.
Yeah.
Yeah.
So yeah. So usually, if we will configure only the default routes, like the default gateway routes only. So if any scenarios like we want some specific routes to be travel towards R2, is that
Towards
possible in
R2.
HSRP?
No,
Means, for example, this
HSRP
is
is not there to basically share the route. HSRP is a protocol, right? These hellos are going between R1 and R2, so that basically they know that who is active and standby. It is not sharing the route, believe me. But yes, maybe you want to ask something different, which I am absolutely not getting. So just think your question through, right? Do not worry about it. We can come to this board again. You ask me this question again, okay? Once I am done with the class. But maybe it's an interesting question, but I am not getting it, okay? But just try to think more about this question, and we will take it at the end of the class, okay? So now let's talk about some of the commands output. Believe me, it is going to be very, very simple. Mr. Mukund, I will be coming to you once I'm done with some of the things. Okay. So if you,
actually, I just want to like the previous question, I want to give some input
okay,
on that question if you allow me.
we can discuss this at the end of the class, Mukund. Do not worry. Okay. Otherwise, these things are going to be going to remain. Okay. Let me complete. I am not saying that we will not be discussing it. Definitely, if a question comes, we should discuss it. But let me complete this. Okay. So if you see this diagram, so I have tried to make this diagram over my EVNG machine, right? We have distribution 1, distribution 2, and this is PC VLAN 1, VLAN 10, this is PC VLAN 2, this is my access switches, that is it, right? And as I mentioned, the configuration is really, really easy. There is no doubt about it. Just go to the interface VLAN 10. This is the configuration of distribution 1. This is the configuration of distribution 2. You just need to configure the IP address 10.2 and what should be the virtual IP address. Port priority I have given 200 so that this switch becomes my active switch when HSRP syncs, right? Then if we talk about VLAN 10 configuration on distribution 2, I have just configured the IP address and then standby 10 IP virtual IP. If you see the output of HSRP, you just say show standby. It is saying that it is running over VLAN 10 for group 10, state is active. This is distribution switch 1. This is right now active. Virtual IP address is 10.1, no doubt about it. Hello time 3 seconds by default. Active router is local. This is the local router, which is the active one, and priority. And then basically the standby router is 10.3 and the priority of the standby router is 100. And priority configured on this router is 200, and that is why it is active. It is as simple as that. If I talk about HSRP properties on distribution 2, of course group 10, right? This is my virtual IP address, and I forgot to mention about the MAC address. This is the MAC address. 0A represent the group number 10, right? And everything else is self-explanatory. So there is no doubt about it, right? We have talked about almost everything here. I have disabled the preemption, means if active becomes standby and then comes again, it is not going to preempt the distribution 2, right? Now let's discuss another interesting thing with respect to HSRP, right? So right now, this is my active router. This is my standby router. An active router is taking this MAC. The MAC address is AC0A of 10.1, right? And you can see VLAN 10, MAC address is this one. Dynamic, I'm talking about learning of access 1. This is actually the MAC address table of access switch 1. If you go to gigabit 0/0 port, it is learning this MAC from here. It is as simple as that. And this is actually the root of spanning tree also. You can see this distribution switch 1. I am asking spanning tree VLAN 10, and it is saying this bridge is the root. That is why I'm learning from here, right? If this is down, then definitely I will be learning this MAC address from here, as simple as that. And when active becomes standby, it is going to send the gratuitous ARP. We understood it, right? Now, what I would like to tell you is something about the packet capture. If I see this HSRP hello messages, these are going to be looking like this, right? So I am capturing the message from a standby router, and in my case, there are only two switches, distribution switch 1 and distribution switch 2. Right now, distribution switch 2 is my standby router. Its IP address is 10.2. 10.3. This guy's IP address is 10.2 and the virtual IP address is 10.1. This is the topology, right? Believe me, what is going to happen? HSRP protocol is just going to build its message, HSRP. What it is going to write inside it? It is going to write inside the group number, which is 10, and the priority. Priority from distribution 2 to distribution 1 is 100. But when D1 sent, it is going to be 200. All this information, believe me, is going to be encapsulated in UDP. I will be discussing about why UDP. UDP is having source port and destination port of 1985, right? So if I received a message in which UDP says it is for port number 1985, the router understand this is the HSRP message. It is as simple as that. And of course, over IP, I am going to deliver it. IP is going to have the source IP and destination IP. Source IP is going to be 10.3 for sure. Destination IP is going to be what? Destination IP is here, the multicast address. The multicast address is, by the way, guys, which we are going to learn from next course, right? So right now the multicast address, if you see, it is actually 224.0.0.2. This address belongs to all routers. If I have any router, believe me, it always listens on 224.0.0.2. Then it is going to be sent over the Ethernet. As simple as that. And distribution 1 and distribution 2 switches is having trunk link. Of course, it is going to have .1q trunk. Why I am explaining you all these things? So that you can understand, right? You can understand this capture, this packet capture. Believe me. It is very, very easy. If I talk about HSRP message, here is the HSRP message. It is having priority value of 100, group is 10. It is the standby message. It is saying that I am in standby state because it is sent by D2 or distribution switch 2. Really, really interesting. And then it is sent inside the UDP protocol. You can see the source port is 1985, the destination is 1985. Then the internet protocol version or IP, source address is 10.3 right here. Destination is 224.0.0.2. We haven't understood anything about multicast. Believe me, I will let you know when we cover the multicast portion. Of course, it is going over the trunk link. Over the trunk link, if we need to send something, it should be having the VLAN. And VLAN is 10, which you can see right here. And of course, on top of it, it is sending the message in the destination destination source and destination MAC, which you can see right here. This is the overall thing, right? But in the Hindi class, somebody asked, if HSRP is solving the problem of the gateway, why you are using UDP? Can we say HSRP is a layer 4 protocol because you are using UDP? Then believe me, it's an interesting discussion. And I would like to have that discussion with you because most of the times in interviews, I have seen this discussion going on, right? So for that sake, I am explaining you this thing. And I will take example of two routers, router number 1, router number 2, and if suppose they are running BGP, what exactly BGP does, you all know, it just exchange network layer reachability information. Not worry about this word, these are just your routes. As simple as that. BGP exchange routes, but it can exchange routes in very large quantity. It's a scalable protocol, but its main job is to exchange routes. It is solving the layer 3 problem. But people says to send your BGP messages, you need TCP, right? BGP uses TCP to send its messages. If you do not know, please have a look at my course or anything, anywhere where you can read BGP. To send its messages, BGP use TCP, which is a protocol at layer 4, transport layer protocol TCP, right? Which is used by BGP. It means that before sending any messages, BGP creates TCP connection and then send the BGP messages over it. Now people say, if that is the case, BGP should be layer 4 protocol because it is using TCP. And it is a point of discussion, right? What should we do in such scenarios? Believe me, guys, and maybe I am wrong in previous videos also, but I have checked my knowledge and now I come to the conclusion that it doesn't matter what a protocol uses to exchange its messages. If BGP uses TCP to exchange its messages, it doesn't mean that it is a layer 4 protocol. The identity of protocol is what actually it is doing. The whole sole problem BGP is solving is basically to let us know about the routes in the network, right? It is solving the problem at layer 3. I would say it's a layer 3 problem. As simple as that. What is the HSRP protocol which Mr. Rahul developed, right? You all should understand Rahul developed this HSRP messages, right? Which is going to take the priority value, which is going to take the group value, and so on. This is the hello message, right? Mr. Rahul is not at all interested in developing a new protocol to send these HSRP messages, right? BGP developers were not interested at all in developing a new protocol which can send these messages, which can send BGP messages. So they used TCP. HSRP developers used UDP so that these messages can be delivered. They choose a specific standard port of 1985 so that whenever a message is received at 1985 port, router understand that this is basically for UDP, as simple as that. So if somebody says, what layer HSRP protocol work? And if you say layer 3, then they can say, but it uses UDP. It doesn't matter. UDP is used to just send the HSRP messages. Just see the packet structure, guys, right? The whole sole problem which HSRP is solving is actually very simple. It is just the gateway redundancy protocol. If one gateway fails, it makes another router up as an active router. As simple as that, right? It is solving problem at layer 3. HSRP is a layer 3 problem. Or a protocol, you can say. As simple as that, right? So at